Black box AI refers to systems whose internal reasoning processes are not directly interpretable by humans. This video explains why many modern AI models are opaque by design, what that opacity means in practice, and how it affects trust, accountability, and responsible deployment. A black box system accepts inputs and produces outputs, but the internal transformation remains hidden. The term does not imply secrecy or intent, but limited human accessibility to internal mechanisms. Opacity is not deliberate concealment. It emerges from complexity, scale, and how learning-based systems represent information. Earlier AI relied on explicit rules. Decisions could be traced step by step, enabling transparency. Rule-based systems allowed human inspection of logic and assumptions. Modern AI replaces explicit rules with learned parameters derived from data. High-dimensional models operate across thousands of interacting variables simultaneously. As parameters grow into the millions or billions, individual contributions become unintelligible. Neural networks distribute information across layers, eliminating single decision points. Behavior emerges from interactions rather than explicit logic. Models learn abstract representations that do not correspond to human concepts directly. Internal states encode patterns statistically, not semantically. Training optimizes accuracy, not interpretability. Objective functions hide trade-offs behind numerical targets. Learning occurs through iterative adjustments without human-readable logic. Stochastic training introduces randomness, reducing reproducibility. Larger models increase performance but reduce transparency. Engineering incentives favor effectiveness over explainability. Opacity persists because it delivers measurable gains. In low-risk applications, black box behavior may be acceptable. In high-stakes contexts, opacity increases risk. Explainability and accuracy often conflict. Local explanations provide insight into individual predictions. Global explanations summarize general behavior. Post hoc explanations approximate reasoning after decisions occur. Explanations are interpretations, not ground truth. Misleading explanations can create false confidence. Humans project meaning onto outputs. This creates an illusion of understanding. Black box does not mean unknowable, but incomplete. Auditing evaluates behavior rather than reasoning. Stress testing reveals failure modes. Monitoring detects drift and degradation. Documentation clarifies scope and limitations. Governance adds oversight controls. Human-in-the-loop systems mitigate risk. Simpler models offer transparency at cost of power. Hybrid systems balance rules and learning. Regulation increasingly demands explainability. Risk tolerance varies by domain. No single transparency solution fits all contexts. Transparency exists on a spectrum. Designers choose where to position systems. Trust often precedes understanding. Responsible use acknowledges limits. Clear communication prevents misuse. Awareness aligns expectations with reality. Research continues on explainable AI. Opacity is a structural property, not a flaw. This concludes Playlist 1.6, revealing how AI truly works.